I'm really, really excited to welcome David Lobster, who's visiting from New York just to teach us all how to do these things. David just spoke to us about therapeutic VR last week, so if you watch the stream, you can see his talk. And he's spoken to us about a couple of other projects in the past. He's this incredibly talented artist, developer, animator, technologist who does a lot of really creative experiments with what's possible with technology and with ideas. David's going to be talking about 2D assets to 3D in Unity today, and then later on Thursday, going to be teaching another workshop on shaders that will be a little more advanced and get very, very advanced with computer shaders in the evening if we get there. Today's talk will be partly a presentation initially, which we are streaming, but then a lot more hands-on as we move through the day, which we probably won't stream. So those of you who are participating on the stream, I encourage you to try to get here to the lab so we can work on these projects. And I could spend a long time. David's done a lot of teaching around creative coding and VR and XR and projects, and I could spend a long time talking about his work and expertise, but I will let David take it away. So thank you.
Thank you so much. So I put this workshop together as a way to get people who have good taste and who want to make things in 3D, which can be in VR or AR or games or just regular 3D animation. And they want to sort of take things, make them look just how they want them to look, and bring them into 3D space with as little friction as possible. So this workshop is kind of for people who are photographers or painters or illustrators, or people who just want to art direct and share their ideas and turn those things into 3D objects as quickly as possible. So I guess I would be curious, and if you're watching the stream, if you can chime in, I'm kind of curious where people are sort of with that spectrum in terms of like your background and your skills and your interests. If you are a 2D artist that wants to bring your stuff into 3D, raise your hand or like chime in the comments. Okay, cool. So you don't have to be an expert 3D artist or designer or whatever for this workshop. This can also be just like a nice way, a nice set of practices and techniques that will work in lots of different 3D programs to just take your ideas and sort of ramp them up really quickly so you can start seeing things and designing things and sharing your ideas with other team members as quickly as you can. So I don't know if we shared prerequisites for this workshop, but I was not planning to go over basic Unity. You only need basic Unity for this workshop. So if you kind of know how to open it and interact with 3D objects, unless I should I go over like a quick, like?
I think it's not a bad idea, just to do like a quick refresher of what the interface is, because there's definitely pieces.
Okay, so I'll go over like a very quick, like high level, like Unity, like how do you open it up and like interact with windows and like what the camera view is and the scene view and stuff like that. And then other than that, some knowledge of 2D photo editing programs so you can prep your assets. So that can be Photoshop is pretty much the main one that everybody uses. I'm going to be hopping into a web-based photo editing tool called Photopea. I always thought it was Photopia, but in a Q&A, the creator of this site explained that it's actually pronounced Photopea. So this is a Photoshop clone that runs on the web, and you can just go to photopea.com to use that. So if there are, let's see, maybe I'll share a couple examples first of like the kinds of things that we can make with this technique. Yeah, so with my studio, Object Normal, which is a studio that I operate with Scott Garner, who probably many of you know. We have created a number of projects that use these techniques sort of in bigger and smaller ways. We did a project for The Economist called Oceans VR, and we used a paper cutout style. So we did use a mix of 2D and 3D assets, but all of our characters were actually all built in 2D. So this is a VR project, but it's a 3 degree of freedom VR project, so people can't get up and walk around the characters. So because of that, it was totally acceptable and fine and preferable actually for us to work in a way where we built a lot of the assets and all of the characters with bits of like 2D art, basically. So we made these paper cutout shapes and we rigged them up. They're all oriented to the camera. And that's how we did the animation.
And play a little bit of the video or scroll through the 3 photos just so they can see.
Yeah,
This,
so
all this
here's-
artwork is, pretty much all of this artwork is actually 2D, composed in 3D space.
Yeah, we'll zoom in a little bit. So you can.
And maybe during the break, it's actually on YouTube in 3D, so you can check that out as well.
Yeah, and we had to learn a lot in terms of optimizing things, and I'll go over a little bit of what we learned in terms of how to optimize for 2D things. There are a lot of huge advantages, especially when you're running real-time graphics, but there are some disadvantages you need to account for. So all of this water, for instance, is layers of 2D sprites, which I've used in various different projects, and I find that to be a pretty successful technique for water in particular. So this Earth is a real sphere, but this whale is a bunch of cutouts. Can't see the sun over here, but we made a very nice looking sun that had animation that sort of flowed along sort of alternate UV coordinates, which is sort of an advanced technique. Maybe we can talk about a little bit later. The first time I used this technique heavily was actually quite a long time ago when I used to be an animation director, and I did this spot for MTV. And this uses almost exclusively 2D art in 3D space. And this was done with Maya instead of Unity, because Unity didn't exist then. Those are my darker days. So this character and the dog, they're all just photographs that I put in there and rigged up. And because I didn't need those characters to rotate around, it worked great. I didn't need a team to do it. I was able to do it really quickly instead of spending 2 weeks just building and rigging those characters, which would even be ambitious in terms of the amount of time it would take. It took me a couple days, so I was able to do this whole spot, I think, in 2 or 3 weeks, as opposed to 2 or 3 months, which it might take if I was doing everything with real 3D assets. So this is just another, this is a still frame. This is from an augmented reality project from a group show that Scott and I participated in called MOMAR. So if you look up MOMAR, and then AR maybe. So it's AR at MoMA. We took over a gallery at MoMA and showed a bunch of different artworks by different artists, mostly from ITP. And this was my piece, and it was about QAnon, but this was all the way back in, when was this, 2016 or something? It was like before most people knew about QAnon. I had one friend in particular who was sort of falling into that rabbit hole, and so I did a little bit of research, and I thought it was pretty interesting, the iconography and some of the ideas. So this image has a 3D asset, and that is this building and these walls, and almost everything else is a 2D asset that I placed in there. So again, a huge advantage of this technique is that I could do this entire scene really fast. I basically built this whole thing in a day, as opposed to if I actually had to model all this stuff and like really make it, it would have taken me many days, if not a couple weeks, if I actually wanted to like model and texture and work in a way that's sort of a more traditional 3D workflow. So it might be that you want to do things properly and actually model things and texture these things. But if you're looking to do R&D, if you're looking to communicate to a team, as a creative person, if you have technicians and other artists that are supporting you potentially, this is a really nice way to create things quickly and iterate quickly and lay things out and try out ideas without committing to building a whole lot of assets right off the bat. You get to see things in 3D space. You get to have a sense of like how close and how far things are, which is really important with VR because like you have to deal with things like parallax, and if there's too much of a difference between things that are close and far, you get double vision and things like that. So there's lots of things you can experiment with and try out and work through using these techniques. And then it can actually also like work great as a final product. I think that 2D is underutilized in VR, but I've seen some really great projects that do use 2D techniques to really good effect. So it's like, if you know that you don't need somebody to walk all the way around your object, then you don't lose much at all by just sticking to a purely 2D workflow. All right, so this is a project that I did with a psychologist named Deirdre Barrett. She teaches at Harvard and she studies dreams. And we did a series of lessons about dreams. And the way that we got it together was using collage techniques. So all of these assets are flat. Let's see, is this the VR version? So I have a VR version you can actually look around as well, so you can see what it looks like in stereo. So I can share that link with anybody that's interested. But there's not a single 3D asset in this scene. And when you're in VR, you can definitely tell that they're flat, but it's totally acceptable. Like nobody complains when they're looking at it that, oh, I'm looking at a bunch of flat things. The clients had some concerns that it wasn't going to feel dimensional or VR, but all of these assets are laid out in 3D. So you actually have like a really nice sense of depth. So again, it was like allowed us to work much more quickly and have a lot more flexibility. And we were able to make things look just the way that we wanted them to look without having to have a huge team to do this. It was, a tight schedule and a low budget, so it helped with that, but it also helped us create the look that we really wanted. So even with a bigger budget, and even with a longer schedule, I probably still would have wanted to use this set of techniques because it was pretty effective for this particular kind of content. So this works because this is not a VR experience for people to get up and walk around and look at this stuff at different angles. It works because it was meant to be a almost theatrical kind of performance for people who are sitting in one spot, and maybe they can move a little bit, but not too much. So these 2D techniques are especially good for experiences that are like that. So I have a few different videos. I think I'll not share the other ones now, but if anybody's interested, I can post some links later. So that's sort of an intro to what we can do with those techniques. So if anybody has any questions, maybe I'll pause there for a moment and see if I can answer any questions before we go to the next thing. Okay, so yeah, actually I do see one from Max Headroom, 3D scanning and with photo and video. Okay, so there is techniques that involve photogrammetry. There's a tool called reality capture. There's a bunch of other ones. There used to be really great ones for free, but as far as I can tell, none of them are free anymore. If anybody knows a really great photogrammetry tool that's free, please share it.
Maybe don't have this up.
Okay.
This is what's going to the screen. Look at the screen real quick.
Yeah.
So just maybe don't go here and sit.
Oh, you don't like Infinity? Okay.
Well, also just because anyone can post anything to that chat, so let's just open public YouTube chat.
Fair. Well,
Sorry, you're talking about.
Yeah. Let me move it away just to make sure that I can have that over here. Okay, great. So something that you can do in terms of like 2D to 3D. One way to work in that space is to take, let's say, 50 photographs of an object, and then you can use tools that will convert that into 3D objects, and you can use that. So there is no reason that you can't mix these techniques. So I'm going to be showing you how to do sort of more like photo collage as opposed to making real 3D models. But you can mix both. So let's say you are in a world where there is an object in the center and you want to be able to walk around it and you want it to look the same and have the same style as objects that are on the outside. You can use these flat 2D assets and put them all around the outside of your environment because you won't be able to walk around to the back of them. And then you can spend the extra time that it takes to make a really nice 3D scanned, photogrammetried 3D model in the center of the space. So should I pop up a little more info about that for people that don't know what photogrammetry is?
If you want to go into it, that's not really what you were going to talk about today, right?
I'll just pop this up really quick. There's a...
And we do also have that setting 3D scanners and things like that for creating 3D assets, but David's focus today is much more 2D.
Yeah, so you're probably, I mean, like this is pretty ubiquitous now. You probably see in apps that do this, but the idea is you just take photographs of things from lots of different directions. They can make point clouds out of those, and from point clouds, it can make 3D assets. So we're not going to be talking about that today. But as I said, you can mix them, and these are also very powerful techniques and worth their own workshop. So if there aren't any other questions, maybe I'll just hop into a
I
quick.
have one other question. You talked about like performance and didn't really talk about what you meant. Not like, what are the advantages to this other than just like the art advantages? Like, what are the technical advantages to this approach?
So yeah, I'm going to get into how to deal with sort of the pros and cons of performance a little later, but in general, because we are going to be using these 2D assets, the vertex count of the scenes that we're going to be building is much, much, much lower. So that could be as simple as, for any asset in this scene that we're looking at, instead of having, dozens or hundreds of vertices for any one of these objects, it can be as few as 4 vertices for any of these
I don't know that
objects.
everybody knows what a vertex is. Can you show the wireframe of this view just to see that they're just squares, right? They're just rectangles.
Yes. So unless they're sprites, so some of these things these are actually mostly sprites. So Unity, and I'll get into this again later. So when you make a sprite in Unity, it's a bit different than making a quad with a texture on it, because Unity will actually sort of build geometry to cut shapes out. So there are more vertices. Like this is an example. Let's see, do I actually have any quads? I don't even have any quads in here. So even with these extra vertices, it's actually more performant than actually building an object that has smooth curves like this requires a lot of vertices. And if you see a mesh, like every one of these points is a vertex, and the more of those you have in your 3D scene, eventually you run into bottlenecks and the performance can drop. So in VR, sort of in mobile VR, which is a place that Scott and I do a lot of work because it sort of makes VR more accessible on more devices, there's a sort of rule of thumb limit of around 100,000 vertices in a scene. So that's not a hard limit. It depends on some other things. It's possible to have much more than that, but it's definitely not possible to have millions of vertices. If you're working with PC VR, you can get up into the millions of vertices, but if you need to be working in a way where vertex count is important, then these techniques can really help with that. In this scene, this cactus will actually rotate to the camera, so I'll show that in a bit to see what happens when you actually move around an object. So it works especially well with sort of symmetrical objects like pine trees. If you're moving around them and the object is rotating to face you, it's actually pretty acceptable. Like our brains don't necessarily think that that's very weird. So definitely, if you do want to move around an object, you can rotate it to always face you. And then there's another technique which comes from the very early days of computer graphics. If you ever played Wolfenstein or if you played Doom, all of the enemies in those games are not 3D objects. They're actually quads, so they're squares with images pasted onto them. And then the game knows if the enemy is supposed to be facing you or facing away. And based on that, it will actually show a different image. So they have images where it's from the back, from the side, from the front, and based on where the camera is and how the bad guy is rotated, it will show you different images, but the quads are actually always facing the camera directly. And that is also a technique you can use. In the space, I actually built a school of fish that uses this technique. So I wanted to build a whole bunch of fish, but I wanted them to be able to face in any direction. So I actually built a sprite sheet of the fish rotating. And then in the shader, it knew what direction the fish were supposed to be facing and displayed a different image, even though the quad was always facing the camera. So that's an unusual technique to use in this day and age. I would say it's not actually use that much, and there are some disadvantages to it. Mostly that there's kind of a limit to the number of different angles you can have, because you will run out of texture memory pretty quickly. And there's going to be kind of, unless you cleverly fade between them, when you switch from like the front to the side, you're going to be looking at a different image. So it's going to sort of pop to being a different image. So when you're playing Doom and it's 1995 and it's the first time you've been in a 3D space, it's very acceptable, but a little bit less acceptable in this day and age. So yes, billboarding is the term for that. So billboarding a sprite is the process of taking a quad and having it always face the camera. Okay, so I'm just going to do a very quick and dirty review of Unity. So I guess I'll reset my layout. So when you open Unity, it's going to look a bit like this. I'm going to make a new scene, just a basic scene. So this is what you should see when you open Unity. If I Alt left click, I can rotate. If I Alt middle click, I can pan. If I Alt right click, I can zoom. Your keys may vary. I don't think I changed mine, but that's how mine are working. This is the scene view. So this is basically, there's a work camera that doesn't really exist, and this allows you to sort of move around in the scene. Because this is a game engine, you can also, if I am right-clicking, I can look around. So the difference there is if I'm rotating around an object, whereas if I'm looking around, I'm rotating from the camera's perspective. And then while I'm doing that, I can use the WASD keys to move around as in a video game. And then I can also hit the Q and E keys to move up and down. So all of these interactions can be handy. If I select an object, whether it's in the hierarchy or in the scene view, I can hit F, and that will focus on that object, and then I can rotate around that. If I select an object in the scene, I can hit F in the hierarchy. If the hierarchy can get quite big, I'll explain what the hierarchy is in a second. I like to organize my windows a little bit different, so I'm just going to do that. So I like to have my game view over here. The game view is what your main camera sees. So if I rotate my main camera, I see it over here. In the game view, I can't rotate or scale or do anything. It's 100% controlled by whatever the camera in my scene is looking at. I like to move my hierarchy down here to make it close to the inspector, because you're often dragging things from the hierarchy into the inspector. And then I like to put my project window next to my hierarchy, because I'm often dragging things from the project into the hierarchy or vice versa. And then I like to keep my console up to see what kind of errors I'm getting. So something's going on there, but I don't think it matters. So I'm just going to hit clear to get rid of all of my error messages. So these are the windows that I tend to have up all the time. The project window is a mirror of your Explorer or your Finder. So these are files that exist on your computer. You can drag things from your Finder into the project window, and from the project window into your hierarchy. Everything that exists here exists as a file on your computer. And this is sort of unusual, like most programs don't work exactly like that. I'm not sure if Unreal does. Maya never did. After Effects doesn't really work like that exactly. It actually took me a minute to realize that that's what was going on with the project window, but it's great, and it makes it easy to organize scenes, and it's just like, it's an exact mirror of what's happening on your hard drive. The hierarchy is your main way of working with files that Unity creates. So Unity's main kind of file type that you're going to be working with is .unity files, which are scene files. And scene files are the place that you take all of your assets and put them into space that you can then work with. So everything that happens in Unity takes place inside of scenes. So if I have a object, let's see, do I have any objects? I think all I have are textures. So if I go into my project view, these are all the files that exist in my scene. Anything with a little arrow signifies that this is a texture that happens to be a sprite. And if it's a sprite, I can just drag it into my hierarchy. So I'll just go ahead and drag some random sprite into my hierarchy. So boom, it just shows up. I can do stuff with it. Q, W, and E are tools to switch between different kinds of transforms. So, sorry, W, E, R are the different ways to do that. So W is move, E is rotate, and R is scale. And the reason that it's WER is because those keys are right next to each other on the keyboard, as opposed to S for scale, T for transform, that kind of thing. So these handles let you interact in different ways. Something to note is that there are these different interaction modes. So pivot, so there's local and global, and then pivot and center. And that's the difference between, are you rotating things from an object's local center or from a whole group, or are you sort of moving things in, so now that I've rotated this object, I can move it up, but it's in the objects up. I can switch to global and I can move it in the world up. So just know that these are there, and if things aren't moving around or doing quite what you want, it might be because of these kinds of things. So if I select both of these and I'm in center mode, I'm rotating them around a shared center. If I'm in pivot mode, then each of these are rotating around their own center. So that's the main difference there. So I'll talk a little bit about hierarchies and local space and object space, but just know that those are there. So the last thing to look at is the inspector. So the inspector has, so everything in a scene in Unity is a game object. So if I go up here to game object and say create empty, every game object has a transform, and the transform tells the game object where the object is in 3D space. So it has a position, a rotation, and a scale, and everything else is about components being added to that game object. So every object can become every other object just based on adding different kinds of components. So a camera is a game object, it has a transform, and it has a camera component and an audio listener component. So it can also hear audio. A light is a game object that has a light component. These mountains are game objects that have sprite renderer components. And I can just add components down here, and this is a list of all of the components that we could potentially add. We're not going to be worried too much about adding lots of different kinds of components, but just know that every kind of game object in Unity can become any other different kind of game object just by adding and removing components. So this is where all of the interaction with parts of objects come from. So I think, did I miss anything, Scott?
That's a good start. I think one thing for the people in this room just to keep in mind, David has a slightly different version of Unity than you have, so yours could look a little bit different, but all the rules definitely apply. And like you mentioned, he is on a Windows PC, which will be a little bit different from a Mac, but the Unity documentation is also quite good. And some of these things just take practice, like which keyboard shortcuts to use and all that kind of stuff.
So yeah, I mean, Unity can get very deep, obviously, but in terms of the basics, something that I actually really like about Unity is how simple the interface is and how you can like really just get right into starting to create things very quickly once you kind of get like these basics of what I just explained. So I'm going to go ahead and start with a new scene. Oops. Let's see. I have things showing up on different windows and I'm still not used to where I need to drag over here. Okay, so basic built-in scene. And I'm just going to start by making actually, I guess what I'll show you first is this scene that I call boring room. So this is kind of a typical way of working with 3D graphics that is totally acceptable. But you will see, and this is like the traditional way of making rooms is you have geometry and then you get tileable textures and you put it on that geometry and then you do lighting later. There's a ton of huge advantages to working this way. So there is a reason that this is the standard way of working, especially if you're moving around and looking a lot of different directions. If you don't have a fixed perspective, then this is really the way that you want to work. But it does have some disadvantages in that, it's harder to make things like really look the way that you want them to look. It's hard to kind of get everything working together nicely. And it tends to, if you don't take extra time, it tends to create scenes that look very computer graphic-y, I would say. So to me, this room feels fairly computer graphic-y. I have a wood texture for the floor, and I have a brick texture for the wall, and I have a sort of simple noisy texture for the ceiling. And it's fine. This is like the normal way of working. The textures look like, let's see. So this is like what the wood floor texture looks like. Simple, tileable. I can apply that to a material and then add that to the floor. So maybe I'll just go through that process really quick. So if I want to create a new material, I right click in the project, create material, new wood floor. And then there's a couple ways I can get my textures in here. One of them is I can select this, and then I get a list of all the textures that are in my project that I can choose from. The other way I can do it is to drag materials in like that. And then from here, I can adjust tiling. And then I can assign this material to an object in my scene by dragging it directly into my scene or onto the object in my hierarchy. I can also assign it by going into my floor object, finding my renderer component, going into my materials array. And it's an array because some objects can have multiple different kinds of materials, but I can also drag that directly onto there. So I'm showing you this stuff just to show you kind of the typical way of working with textures and materials in 3D space. You will likely be combining these kinds of more standard techniques with the photo cutout techniques for things like floors or ground planes in particular. It's like much harder to do things with this like 2D collage cutout style I'm going to show you. But maybe I'll just pause there really quick and see if anybody has any questions about, I did that pretty quick, making a material, assigning a texture, and assigning that to an object. Are we, even though I did that quickly, are we kind of okay with that, those general concepts?
One thing that Briefly mentioned is like, where did those files come from? Like, where did that come from? Where did the floor and wall,
Good question. There is an amazing website that's been around forever called CG Textures. And it has tons and tons of stuff, and a lot of it's free. You can generally get lower resolution textures for free, and then you pay a bit to get the higher resolution textures. So if I just type in wood floor, there's a ton of stuff. And the nice thing about this site as well is that it often comes with separate maps for things like shininess and bump and normals. So I'm not going into how to work with these different material property channels, but there is this idea with real-time graphics where you can use shaders that are called PBR shaders, which is like photorealistic shaders, basically. So they include the ability to have maps that control areas of a surface that are more and less shiny and how bumpy they are and occlusion and like all different kinds of things. You can combine maps, different kinds of maps in different ways to create these higher end materials. We're not going to talk about any of that, but this stuff is necessary and useful if you do go in the direction of wanting to do more high-end kind of 3D stuff. But that's not what we're doing today. What we're going to do is start with an image of that wood floor, let's say, or whatever it is that you want to use, and just use it directly. It's just going to be A to B. It's going to be a photograph or it's going to be a painting, and we're just going to put it in 3D space, and we're not going to have to worry about any of these material properties. Okay, so I'm going to hop in and make a sprite and bring that into, maybe I'll pause real quick and show people where this repository is. So I'm going to be showing you how I made this extremely cool scene. And you can get it on GitHub. So let me show you where that is real quick. Okay, so you don't have to know GitHub to be able to use this. If you do know GitHub, then what you're going to want to do is clone this repo into your assets folder. So if I go into my Unity project, I have an assets folder, and then under my assets folder, I have the SETI 2D to 3D folder. So if you know Git, you can go to this repo, github.com/dlobser/SETI_2D to 3D. Yes. Yes. Do I put it in the private chat? Is that the idea?
No, in the comments.
Or if you put it in private. So
Yeah, put it out there.
Yeah, I don't think I have access to comments, so.
Okay. I wasn't sure what your size was.
Yeah, so if you know Git, clone it directly into your assets folder. I'm going to be making stuff today, and I'm going to push it up there so you can grab anything I might make. But if you don't know Git, that's totally fine. What you're going to want to do is click on code, and then click on download zip, and then you're going to decompress that file. So you should have a folder called SETI 2D to 3D. And then you're going to drag that into your Unity project under your assets folder. So you can have your Explorer window open and then just drag directly from there into assets, and that folder should show up. So I'll just give everybody a second to do that.
You also just drag it right into the project.
You mean like in the Explorer? Like in
Without
Finder?
it, we don't even use Explorer, we'll just drag the 2D to 3D into the assets. That's okay, I just tried it, that works.
Yeah, there's lots of ways to get it in there. You can use the Finder, you can use the Explorer, Explorer to Explorer, Finder to Finder, or directly from like the compressed folder, like directly from whatever zip program you're using, like directly in Unity. So lots and lots of ways to do that.
And which scene should we be looking at?
No particular scene just yet, but it will be under
Just start with room.
SETI, under scenes, room. But I'm actually going to just start really quick with just making a sprite from scratch and bring it into an empty scene. So I'm actually just going to start with an empty scene first.
So, this is what.
Okay, while everybody's doing that, I'm going to go into Photopea, and I'm just going to make a cool image. And since this is not a Photopea workshop, you don't have to pay close attention to this part.
What's that? Oh, you told me about it. My muscle is just full control. Yeah, I think I can just drag it into that. Drag it into that.
How many warnings should I expect?
Hundreds of more.
I did sort of, I included a bunch of random scripts, which may have some complaints in them.
Yeah, so that's the VR satisfaction. And I think it's just because David has an older version of Unity, and so it's not even broken, it's just telling you in the future it won't work. So it's just an obsolete message.
Yeah, so part of this workshop was also sort of like actually going all the way into creating interactive scenes in VR, but we're probably not going to get that far. Maybe we'll get that far. If you want to come to the workshop in the afternoon, I did bring my VR headset so we can actually look at the scene that we're going to build, or any of your scenes actually, if you want. We can show what they look like when you're walking around inside of them in VR. Okay, so I just wanted to make like a quick sprite in Photopea. And so when I say sprites, that kind of has different connotations. Like the word sprite comes from the very early days of computer graphics, and it's a way to refer to space in memory where like a texture has been assigned. So I think it's like sprite is in reference to sort of sprightly, ghostly creatures that exist in memory and are displayed on screen in a certain way. So there are some specific like technical meanings behind what sprite is. When I refer to a sprite as opposed to a 2D texture or something else, generally what I'm referring to is something that is made to be dragged into a Unity scene and to exist on its own as a 3D object, as opposed to a texture that might live on a 3D object. And usually a sprite is going to have a transparent background. So in this case, I've just made a circle and it has a transparent background, and that means when I drag it into my scene in Unity, I'm going to see a circle and not the empty space around it. So so sprites can be tinted in Unity. So by default, good practice is to always make white sprites. Even if you're definitely going to have an object that's for sure going to be black, go ahead and make it black. If it's for sure going to be red, go ahead and make it red. But if you'd like to decide after the fact, if you make it white, it's very easy to recolor it later. So I want to make let's make it a smiley face. And then I'm going to want to be able to change the color in Unity. So happy. All right. So I'm going to export this as a PNG file. JPEG files do not include transparency. SVG files are a file format for vectors, and Unity does have a plugin that allows you to read SVG files, but in general, that's not something you want to do. GIF files, I don't know if Unity can even read those. Never use GIF files. They're totally not optimized and only good for memes. Unity will read PDF files, but there are some issues with PDF files that I have run into. So in general, if you want to just like get what you're seeing and what you expect, PNG files are the way to go. They are, it's a compressed format, but they are losslessly compressed. They generally look much nicer than JPEG files. So I'm just going to save this smiley face. Call it smiley sprite. So when you save something in Photopea, it just goes directly to the downloads folder. All right. Okay. So something that I do, I tend to work out of my like base level assets folder when I'm just kind of making a mess and I'm just like making stuff and I'm not sure what I want to keep. Another way to work is that's a little bit cleaner would be to make, let's say, a work folder. So a work folder is just a place where I'm going to put things and I'm going to organize them later. So for now, I'm just going to drag my smiley sprite PNG file that I just saved from Photopea into Unity. And this pops in and it has a black background. And that's just PNGs kind of doing their thing. It's like because that was transparent, the PNG saved it out as black. But we are going to get rid of that by setting the texture type in the inspector. When I have the smiley sprite selected, I'm going to set that to sprite. So lots of options here, but generally, most of the time you're gonna treat textures as either default or sprite. So there's a single and multiple mode. We'll get into multiple mode a little bit later, but you can actually build your own sheets of sprites. So you can have a single image with a bunch of different sprites on there, and then you can go in and using Unity, you can select individual sprites. In this case, this is one image and the sprite mode is single. And if I click on apply down here at the bottom, now all of a sudden we have this arrow that comes in. So it has created a sprite, and this arrow is the way that Unity organizes multiple sprites. So if we did make this a multiple sprite and I chose multiple sprites in the multi-sprite editor, which I'll show you later, you would see all of those sprites underneath here. I can drag either the parent or the sprite into my scene directly. So I can drag it in here, I can drag it into my hierarchy. Unity often places objects in weird positions. It's usually placed kind of wherever you're looking. So the first thing that I tend to do is click on reset, just so that I have my object in the center. So that's the basics. That is how you can make an image, bring it into Unity, drag it in, and now we have a sprite. So if I want to immediately start thinking about what things are going to look like in VR, I'm just going to hop in immediately to thinking about like what the scene is going to look like when I put on a VR headset. And to do that, I like to reset my camera to be 0. It's not necessary, but I think it's good practice depending on the kind of scene you're making. So now my sprite is at 0 and my camera is at 0. And I can't see anything in my game view because my camera is exactly in the same spot that my sprite is. So what I'm going to do is move my sprite forward in space. And cool, now I can see it. So this looks good, but I don't necessarily know how big it is. So one thing to keep in mind with VR in particular, but this also applies to AR and games. Also, it's like you kind of have to think about scale. If you start building a scene at completely the wrong scale, it's not necessarily that hard to rescale it, but it can cause complications. So if you think about scale from the get-go, you'll save yourself a headache later. So Unity treats a unit as a meter, and that's true for AR and for VR. So this is, so from here to here is about the distance that you want to socially distance from people who have COVID, let's say. So something that I like to do is create a stand-in object for kind of a person or for an arm's length, let's say. So if I create this sphere, in VR, in general, the closest that you comfortably want an object to come to you would be like about a half a meter. So, about this far. If anything gets closer than that, and you're focusing on it, you definitely can, of course, focus on that. But even if you do this in real life, if you hold your hand up here and you look at it, everything in the background is going to be double. And that's pretty acceptable in real life. You don't really notice that too much in real life. But in VR, you definitely notice when you're seeing double in the background versus the foreground. So this is just a good rule of thumb, like figure out a comfortable distance to always keep objects away from you. And I just like to have a representation in my scene. And that's either a half meter or a meter. So this is a unit sphere. So a unit sphere means that it's going to go from, if I try to like sandwich these in the middle, oh yeah, if I just move that 0.5, and this edge is going to be exactly on a grid line, and this is going to be exactly on a grid line. So if I put this right in the center, then the sphere extends out half a meter in every direction around me. So this is going to be my shell of nothing will come closer than that in my VR world. So what this can also do is help me figure out how big objects are in the world. So the average person is about 1.5 meters tall-ish. So if I just make that high scale, let's see, not position, but scale. So if I set the scale to be 1.5, and maybe I'll shrink these. So this is about the size of a person. So if I move that over here, I now know that this head, even though it doesn't look big because it's just on the screen, in VR land is actually very big. So I want to use that as a base, and I just want this face to be about the size of a human face, which is, more like that. So this is much more normal size, and then I can move it closer, and now I know that that face is going to be about this far in front of me, and it's going to be about that big. So some people create all of their VR in VR. I create very little of my VR in VR because I have these rules of thumb, and I kind of know, it's like a unit is a meter. I didn't really know metric before because I'm American. We don't use metric here. I know how big a foot is. But since I've been working in VR so much and everything is in meter space, everything is metric, which makes way more sense. It's like you get an intuition for some of this stuff as well. So yeah, like most of the time I'm building my VR just on the screen and just putting on a VR headset to check it. Okay, so I have my little face, and it's about as big as I want it to be, and it's where I want it to be. I can color it up here. So this is what I was talking about with making it white. I can now make it, let's say, standard emoji color, any other color I want. I can duplicate the face and do different things with it. So different colors, for instance.
You're just copy pasting, or?
Yep, so let's see, Control D or Command D will duplicate, and then you can move it. Let's see, does it also do it Photoshop style? No. Okay, yeah, so Control D lets you duplicate.
Yeah.
So I want to show you a little bit about a way to do cool things with the hierarchy. So this is the hierarchy view, and hierarchy basically refers to the idea that you can parent things to other things. So if you think about a directory structure on your computer, you have your root folder, and you generally don't want to mess with that. That's like where your program files are, or your documents, or your users are. So that's like the high level place. And then you start sort of putting things under there and grouping things for different reasons. So there's two things that you can do in terms of, or two ways of working with groups of objects. And this is true in Unity, it's true in Maya, it's true in a lot of 3D programs that have hierarchies like this. You can use elements in a hierarchy for organization, or you can use them for transformation. So this is kind of a whole topic, and I'm not going to go that deep into it. But I do want to show you that you can, let's say, make a group of faces. And I'm going to reset this because I don't like the fact that it's off in this weird spot. So I'm going to reset that to 0. And then what I can do is drag my smiley sprites into my faces. So now that everything's under faces, I can turn on and off the visibility in different places. So this eyeball is for visibility just in the hierarchy. So if I want to show and hide things in there, this visibility deactivates the object and everything underneath it. So you can see that this makes it invisible in the game view. This only makes it invisible in the scene view. So from here, so this is great in the hierarchy view. Basically, I can roll it up. I have a group of faces. I know that's where all my faces are. If I want to find a face, I have that group. I can poke under here. I can even, let's say, make an empty child, and I can say, I just want magenta faces in this group. So I can put that under there. It goes around. So you can have hierarchies that are extremely deep. As a quick performance note, extremely deep hierarchies can eventually have performance implications. So if you have, let's say you're building a crazy tree with lots and lots of levels of hierarchy, and your scene starts running slow, that could be a reason why. Something else to note is if I have 10,000 faces in my scene and they're all separate objects, the performance is going to start to get slow because they all have their own transforms. If I want to have 10,000 faces in the scene, that's totally fine if I merge all of that geometry into one piece of geometry and control them not using separate objects. So this is a slightly advanced topic, but I'm just going to point that out, that if you get to a point where you have lots and lots and lots of objects because you've been hitting Control D, Control D, Control D, even if your scene isn't really that complex in terms of your vertex count or in terms of your textures or whatever else you might be expecting, just because you have lots of transforms, there is going to be a performance implication eventually. But you have to make a lot of it. You have to have a very deep hierarchy with lots of objects before you're going to run into it. So this is good for organization, but something else to note is that I can also transform these groups. So if I take these magenta faces, I can also move them around. I can rotate them, and I can scale them. All right, so I can move all of these things together. So one place that this is useful is I've set up all these faces. They are happily facing my camera. Right, so I'll never see them from the side, which is generally undesirable using these techniques. But let's say I want to take all of these faces and I want to have them over on the right side of the camera. So I've taken them, I've moved them over. Maybe I've selected all of them and I've moved them like this. So now they're all on the right side. Now I have to go in and rotate all of these individually, which might be easy. In this case, it's easy. I can just kind of select all of them and rotate them around. But a nicer way to do this is to select this top group. Because the pivot of my top group is at my camera, I can just rotate them all around, and now they're all still facing the camera. So this is actually a really nice way to work with these assets that we're going to build when we're talking about building environments in VR that surround us, as opposed to placing and rotating. If you put them under a parent group and rotate that parent group, it becomes a transformation using polar coordinates in a way, as opposed to sort of Cartesian coordinates, which require that you move and rotate. Okay, I didn't mean to go too deep down that particular rabbit hole because we still haven't made that many images yet. But maybe I'll pause there real quick and see if anybody has any questions right now about some of these basic things. Making an image, giving it a transparent background, dragging into Unity, telling it to be a sprite, dragging it into the scene, and putting it in a hierarchy. Any questions about those topics right now? Did I lose everybody?
I think maybe one thing to just comment on is you know, that relatively, there's of course exceptions, but relatively little art is created in Unity. It's much more common to use other tools. And so any processes you're comfortable with for creating art, whether it's drawing or sculpting or whatever, you can do that. And as long as you can make it into an image, you can use these techniques. It doesn't have to be drawn, it doesn't have to be scanned, it can be even just something taken with your phone. If you cut it out, photo feed, you can use these techniques.
Yep, yeah, so there are tools that were written to be used in Unity, but Unity itself does not have anything in the way of asset creation tools. So you can start with photographs, you can start with a drawing that you scan, and all of that. And the only thing that you would really need to do to prepare sprites would be to go into Photoshop or Photopea or something else and cut out the background. Once you've cut out the background, then it can become a sprite. So what I want to show you now is how to do, let's see, I'm going to save this scene. Okay, so now I'm going to pop into the room, and I used the techniques that I just showed you to make everything in this room. So it's not the prettiest room in the world, but I was able to build this entire room in an hour or two. So it has a wooden table that, yes, we can actually move around to some extent. It is really 3D, even though it's built of 2D things. I actually did wind up using this exact asset on a project that I made recently because it worked fine. The drop shadow is fake. The drop shadow is a sprite, and then there are multiple layers of sprites to give it a three-dimensional feel. When I hit play, looks like I broke that script, so I'm gonna have to add that script back in. But the idea with this asset is that as you move around, it will rotate to face the camera. So if you walk up to the window, it will always be looking at you. If you are making an object that is going to rotate to face you, they work best when they're symmetrical or when they're like round things, cylindrical things. If you have some like janky shape, you might run into issues as it'll become more apparent that it's rotating to face you. This tree is built using a shader that actually uses a technique called alpha masking, alpha cutout, basically. It's like a cutout shader where we clip the alpha channel instead of fading it. So if I zoom in really closely here, you can see that there's no transparency. It goes from being on to off. And I'll get into what's interesting and important about that. But one thing that lets us do is have the textures exist in a way where they can pass through each other. And this is also really good for performance. But I'll rewind and come back to that. And then the last element that I have is a skybox. So this is just a 360 image that is surrounding my entire scene. These walls are also sprites. So something that's hard to do, and it's much easier in a program like Unreal, where they have very nice lighting built in, but something that's hard to do in general in 3D is create really nice lighting that just feels very realistic. So what I did here is actually just start with a photograph of a room, and I took the room and I chopped it up and I deformed the bits and then brought those back in as sprites. And what I wound up with is a room that's just made of these textures that is fully acceptable as a space. Like it feels like a room. It doesn't feel like something that's trying to be a room. It's not in this uncanny valley of looking like a video game and coming up short in some way stylistically. So that doesn't mean that this room has to look like this, right? This room can look like anything. It can be your room. It can be a drawing of a room. Like you can make it look exactly how you want it to look. And then by cutting things out and putting them on planes at these angles, suddenly you have a space that you can walk around in, or at the very least, again, in VR, maybe this isn't necessarily built in the best way to like go in and explore every nook and cranny. Because, if I move around to the backside of this table, for instance, it starts to break. What if the idea is that I'm in a VR space or a game where I'm somewhat limiting people's locomotion, which is common. Most VR projects do limit where you can go. This becomes totally acceptable and even better looking than, spending a ton of time building 3D assets and baking in really high-end lighting and all of that stuff. So I was able to do this in a matter of, 20 or 30 minutes, as opposed to hours or even days to build this using traditional techniques.
So the lighting in that room was from a photograph.
Yep, A to B. So and I wasn't able to track it down again because I didn't save it in my repo, unfortunately, but the original photograph basically looked like this directly. And then I'm going to show you now like how to take a photograph that looks like that and chop it up so that you can then bring it into 3D space. So the idea is to get rid of the perspective and then let the 3D program bring the perspective back in. So I think this is one of the trickier things in terms of like taking these sprite techniques, taking these photogrammetry techniques or matte painting techniques. All of these things have different names based on what situation you're in and what kind of people you're working with. But that's like the trickiest set of techniques involve that. And also, things like with this table work the same way. I started with a photograph of a table that was at an angle, and then I chopped it up and skewed them until they were flat and brought them into 3D space. So it probably doesn't mean much until I show you something.
Can I ask a question about the tree in the background through the window?
Yeah.
You mentioned you made the tree with shaders. And is there sort of an advantage to making some of that with shaders rather than with a photograph?
So this tree is not made with a shader. So it is still a texture of a tree. It's using a different kind of shader than these. So I can show you this really quick. Let's see, let's see. I'm gonna try to find an example. Like if I zoom in, might be a little hard to tell, but if I zoom in very closely on this, the edge of this, it's soft, right? There's kind of a transition from opacity to transparency. And this looks nicer, like it looks great. There are some problems, and actually maybe this is a better example. The drop shadow up here is transparent, right? So it can be in front of things, I can make layers of this shadow like this and, kind of like build up these like clouds of 3D shapes and things like that. And it can look really nice. And this is actually a really nice thing about sprites is that 3D objects have hard edges generally. So if you want something that's like ghostly, semi-transparent, atmospheric, sprites are really nice for that. But there is a problem with this really nice quality of sprites, and that is that modern GPUs are set up to not want to deal with lots of layers of transparency. So unfortunately, especially thinking about mobile VR, which is, again, something I think about a lot, if you have more than 5 or 6 layers of transparency, performance gets really bad. Even though the textures aren't heavy, even though the geometry is not heavy, you can only have a certain amount of transparency. So if we use this kind of shader, if you play any modern video game, you see where there's like grass and leaves and trees, you will often like see that this is how they do it. By using this slightly different kind of shader where the alpha doesn't have layers of transparency, the game engine doesn't really differentiate whether this is transparent or opaque. So you don't have the same performance hit that you do with having lots of transparent objects. So this is already like a topic that's like getting into the weeds a bit, but just like different different kinds of processors are different too. So this is the kind of thing that you can't necessarily assume is always the case. But I was, testing out the Oculus Quest and the new HTC Flow, and they both deal very well with lots of layers of transparent objects if they use cutout. If they use regular transparency, not so good. So because it has this sort of on and off quality to the opacity, clouds don't really work as well unless it's kind of stylized clouds with hard edges. But it's like grass and trees and leaves work reasonably well. So basically we get all this complexity without the need to have a lot of geometry.
So it makes sense to, all these techniques that work well in physical diorama development, that they would also work well in Z-based, like what you're talking about, making planes and cutting off, slip them together, it's essentially doing a sprite, and then ceiling fans kind of layering up. So it gives this sense of depth, but it's still the same object. So it's kind of all of those techniques work well in a computer as well.
Yeah, exactly. So yeah, that's actually a really good point, is that a way to, if you kind of think about these spaces in the same way that you would think about building physical spaces, using cutout pieces of paper and painting on glass and stuff like that. If you think sort of metaphorically in that way, that translates directly. And it actually makes it much less mysterious if you're oh, I'm not working with these weird sprite objects. I'm working with paper cutout. I'm working with a pane of glass that I'm painting on, that kind of stuff. That's actually a really good way to think about that. I think somebody might have mentioned that somewhere in the comments too. So yeah, there's going back to the early days of hand-painted cell-animated cartoons. I think it was Fleischer Studios in particular did a lot of really cool work with layers of really nice paintings on glass, and then they would animate their characters walking in the foreground, and then they would move all of those layers of glass, from side to side, and you get all this really nice parallax, and you get this really nice 2D, 3D effect. So you can paint things exactly how you want them to look, stylize them exactly how you want them to look, and they exist in 3D space. So I'm going to show you how to do this trick where we start with a room, and I'm going to distort all of the walls and the floor, and then we'll bring that into Unity, and you can see how we can turn that into a sprite. So it's a little tricky. So one issue, so I just found this very quickly. I will say one issue with this particular room is the fact that these walls don't line up exactly. So the fact that I can't just cut this straight is going to make it more complicated. So I think I'm going to fudge some stuff with this image. I could find another one, but I think this is fine. So I either need to fudge it and drag it down and make it flat, or I need to actually break up this back wall into more sections. So it kind of depends on how lazy I'm feeling, whether I do one thing or the other. So maybe I'll just start with a part of the image that's pretty clear how to deal with, and that's the ceiling. So I'm just going to go in and switch to, I don't know if I'm going to do this whole thing. Polygonal lasso. All right, so I've just selected the ceiling, and now I have pasted the ceiling, so now it's its own separate thing. Now I'm going to, let's see, I think distort should do the trick. So I haven't done this with Photopea, so it might be a little different than Photoshop. Okay, so I'm dragging that side out, dragging that side out. The shift key is not working like I would expect, so this might be a little messy. But the idea is to take that ceiling and warp it so that all of the sides are flat. So something I might do is like drag down guidelines, or I'll just move them up to the edge of the image and see how close I'm getting. So the closer it is to being straight, the better it's going to work in Unity. It's hard, like you can't do this part of it in Unity easily. I just turned off snap because it was, it's still snapping. All right, we'll say for now, good enough. I'm going to, oh, I lost it. Sad. Okay, let me do that again. So, will perspective do the trick? Let's see, so maybe perspective will get me there a little faster. Okay, so in Photopea, you can't undo inside of a tool. Good to know.
Step forward, step backward.
Yeah, so this can definitely take like rounds to get it just right. So you might get it like part of the way there, and then adjust it again, and something that you'll notice is that the image is going to start to get fairly distorted, and pixels are going to get a little bit squished up, but it actually doesn't matter. You'd be surprised when this goes back into Unity and we put it on a plane and it's set up to sort of display the way that it was meant to display, which is redeformed, like those pixels that look really messy in 2D become less messy. Something like this. So this is my room. So unfortunately, again, I didn't save the original image, but I took an image that had all of this stuff and undistorted it until it looked like that. So then I was able to go in, and because this is a sprite that has multiple parts, I could go in and select the ceiling, select the wall, select the floor. Something else I'll point out here is that the walls and the ceiling and the floor and the back wall and everything are next to each other. And something that helps with is if I line up my sprite selection exactly sort of in those spots, like the pixels, like I don't have to worry about pixels being mismatched from each other. So any little imperfections, it's like down here, it's like, because a huge advantage of working like this is that we can kind of smear things from floor to wall and from wall to floor. So if there's little imperfections and I have those imperfections lined up in this way, when I split things up, they'll line up properly, if that makes sense. So I can show you so this is a convex shape. It's good for that, but it's also good for concave shapes. So if I go in and I can find, all right, so this is what a sprite atlas can look like. So I have a whole bunch of different sprites sort of in one image. In this case, I wanted to make this table. And I did the same thing. I found a 3/4 image of a table and did all of these distortions. So I have the side of the table and the front of the table. Same exact deal. Might be a little hard to tell from here, but the pixels in the upper left don't look nearly as good as the pixels in the lower right. And that's because this image was initially taken at this 3/4 angle, where all of these pixels were in the back. So it's just sort of squished in. There were fewer pixels there. That part got more deformed. But once it's in 3D, if I've aligned it in such a way that that's where people are going to be seeing it from, you don't notice. Like it looks fine. So I'm not sure how obvious that is, but Oh gosh, you know what? Now that I'm mentioning it, because I hadn't even like really looked at that that closely, but actually, I put my table on backwards.